look on how to solve by using square roots. So this only works for specific times that I talked about earlier when there is no b term. And we talked about that a little earlier in the slides, and so let's just go ahead and solve some problems. Here's our very first problem. We have x squared minus 400 equals 0. Notice we have an a term and a c term, or I guess you'd say a squared term, and a constant term, and it's set equal to 0, so what we're going to do is we're going to go ahead and solve this. And the way we do that is we follow the 3 steps that are listed right there, or right there. I don't know which way it's going to pop up on the screen. So step number 1, we need to isolate the term or terms that are being squared. Well, the term that's being squared is right here, and that's the x squared. So we need to get that term all by itself. So the first thing we do to fix that is to use inverse operations and add 400 to both sides. Step number 1, done. The term is now isolated, and we're left with x squared. Inverse operations cancel out, equals 400. Step number 2, square root both sides. Now that that term that is squared is all isolated, we can square root it. Now, having an x to the raised to the second power, the inverse operation of raising something to the second power is to square root it. So these two operations, square rooting and squared, cancel each other out, leaving us with just x. This is good. This is really good, because what does that give us now? It gives us the square root of 400. Now, what does that actually mean? Well, that means that we can take our calculator, and it means what 2 numbers can we multiply by themselves to equal 400? Well, 400, in this one you have to do second square root 400 equals 20. Now, it's not just 20, it's 20 and negative 20, because negative 20 times negative 20 gives us 400, and positive 20 times positive 20 gives us 400. So when we square root something, we actually get 2 different answers, and there they are. Let's do another one. Here it is, number 2. This one will be slightly more advanced. We have 5x squared minus 65 equals 0. All right, so what we're going to do here is we're going to do the same 3 steps. Isolate the term being squared, square root both sides, and solve for both answers. Let's do it. The term here that's being squared is the x squared, so we need to get that all by itself by using inverse operations. Now I like to imagine it was just 5x. What would I do? Well, first I would get rid of the 65, and then I would get rid of the 5. So let's do that. Add 65 to both sides. Those inverse operations cancel out, leaving us with 5x squared is equal to 65. Now we still need to get that x squared term by itself before I can square root. I can't square root this because there's a 5 in front of it, or a 5 is being multiplied by it, and the inverse operation of multiplication is to divide both sides by 5. We now have x squared is equal to 65 divided by 5 is, I should know that, 65 divided by 5 is 13. See? And whenever I'm not sure, I always use my calculator. I know some of you are like sitting there like, I don't know, and I can see the struggle on your face. Hey, if you don't know, use a calculator. I have a whole wall of them right over there. All right, now we need to take the square root of both sides, because that x term is the x squared term is by itself. We square root both sides, inverse operations cancel out. We now have x is equal to positive 13, square root of 13, and the negative square root of 13. Now, if we wanted to type this into our calculator, we could, and we'll get a number that is irrational, meaning it just goes on forever. I don't know if you can see it. I don't like rounding it if I don't have to, so I would just leave it like this. X equals positive square root of 13 or negative square root of 13. Another way people write this sometimes is plus or minus the square root of 13. This means the exact same thing. It means the positive square root of 13 and the negative square root of 13. However you want to write it. I usually write it like this, but until we get comfortable with this meaning two different answers, I think maybe I'll just write it the long way. All right. Now, if you did round it to like 3.6, positive 3.6, you have to remember that it's also a negative 3.6. I like just leaving it as a square root. It's a little more mathematically correct because we're not rounding anything. All right, let's do a challenge one now. Let's do one that looks really intense. This one's going to be slightly different than we've seen so far. We have x plus 5 quantity squared plus 1 equals 82. Alright, now this looks funky, but we're still going to follow those three, whichever way it is, those three rules. Isolate the term or terms being squared, square root both sides, and solve for both answers. Now this one's a little different because we have a quantity that is being squared. So we need to get this quantity by itself and then square root. So we do that by inverse operations. Subtract 1 from both sides. I now have the quantity of x plus 5 raised to the second power, which is equal to 81. Now, this term that's being squared, since the whole thing being squared, I can square root both sides. This and this cancel out because they are inverse operations, and now I'm just left with x plus 5 is equal to the square root of 81, and I believe the square root of 81 is 9. I'm still going to check just because I want to make sure I get this right and I don't have to redo this video. And it is. Now, it's not just 9. It's positive and negative 9. Now, step number 3. This is the first time we've really had step number 3 come into play because it says solve for both answers. Well, this is like having x plus 5 equals positive 9 and x plus 5 equals negative 9. What we're going to do is we're going to solve for both of these answers now. So we subtract 5 from both sides, and I get x is equal to 9 minus 5, which is 4. And subtract 5, and I get x is equal to negative 9 and a negative 5, which is negative 14. We have solved for it. Now, just to refresh your memory, what do these two numbers mean? It means that when we graph this quadratic, we have an x-intercept or a solution at negative 14 and at positive 4. That's what it actually means. And hey, this is like almost vertex form, huh? That's pretty cool. So these are our two solutions, our two x-intercepts, because when we're solving quadratics, that's what we're doing here. We are solving using square roots. We are looking for the x-intercepts. All right, I think we're going to do one more, and I don't even know what the answer to this one's going to be. 3 times x plus 2 quantity squared plus 1 equals 16. Ooh, I don't like this, but whatever. Let's go ahead and do it. Step number 1. Step number 1, we need to isolate the term that's being squared. That's our x plus 2 since it's being quantity squared. We do that by subtracting 1 to both sides. Inverse operations cancels out, and I'm left with 3 times x plus 2 quantity squared is equal to 15. Okay, so far so good. Now what we need to do, the term being squared is not by itself yet, so we need to get it by itself. Let's divide both sides by 3 because that's the inverse operation of multiplying 3 by x plus 2 quantity squared. Those inverse operations cancel out, and I now have x plus 2 quantity squared by itself. That's great because we wanted to get it by itself. Is 15 divided by 3 is equal to 5. Now I can take the square root of both sides of this equation. This and this cancel out. Our goal here is to cancel out that squared, but to do that we have to get the term being squared all by itself. We now have x plus 2 is equal to plus or minus the square root of 5. Obviously the square root of 5, we don't have anything that works to be the square root of 5. It's an irrational number, just like the square root of 13 was, so I'm going to leave it like this. Now, is x all by itself yet? No. So I need to solve, step number 3, solve for both answers. Well, I can subtract 2 here and subtract 2, and I get x is equal to negative 2 plus or minus the square root of 5. Now this looks funky. I know it looks funky, but it's actually 2 answers. We have, I'm going to say or, x equals negative 2 plus the square root of 5, and we have negative 2 minus the square root of 5. These are the exact same thing. They're just 2 different ways mathematically to represent it. I like this one because it's a little neater and more organized, just like I like this one because it's a little neater and more organized. But if you want to write it like this, you can. Now we can actually type this into the calculator and get one. So we're going to say square root of 5. We'll do the positive one first. So the square root of 5, square root of 5 equals that, and we're going to add that to a negative 2, and we get 0.236, yada, 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 and then we do the same thing here. Second square root 5 equals to that, and we're going to say that we are, that's supposed to be negative second square root of 5. We're going to add that to a negative 2. And we get negative 4.236. What does it mean? It means that these 2 numbers are our x-intercepts, or they are close to our x-intercepts. I don't like these because they are rounded, but I just wanted to show you what this actually means. This is a number, and this is a number, and they are numbers that will give us our x-intercepts, just like this one did. Should we do one more? Yeah, let's do one more. Let's do one that's a little easier. This is problem number 5. This will be more like one that you guys will probably see. Ooh, this one's a little different. I like it. 2x minus 6 quantity squared equals 144. Now, the reason I like this one is because step number 1 is already done for us. If we look at step number 1 right there, it says isolate the terms that are being squared. Well, we have 2x minus 6 being squared. It's all by itself. There's nothing on this side of the equation other than that term being squared, so we can jump right to step number 2. Let's square root both sides. Why do we do that? Because this is the inverse operation of squaring something. We now have 2x minus 6 is equal to plus or minus the square root of 144. And the square root of 144 is 12. So now let's break it up into our 2 equations. We have 2x minus 6 is equal to 12, and 2x minus 6 is equal to negative 12. That's what this plus or minus means. It means the positive 12 and the negative 12 that multiply to get us 144. Now we solve this to add 6 to both sides. And we're inverse operations. 2x is now equal to 18. Divide by 2, x is equal to 9. That is one of our x-intercepts. I don't know what this thing is. And let's find the other one. Add 6, and I get 2x is equal to negative 12 plus 6 gives us a negative 6. Divide both sides by 2, and we get x is equal to negative 3. These are our 2 solutions, our 2 x-intercepts. So we know when we graph this, it will have an x-intercept here at negative 3 and here at positive 9. That's what these are. We are solving for our x-intercepts by step number 1, isolating the term or terms that are being squared. Step number 2, square root both sides. Step number 3, solve each equation. I hope this has been helpful. I'm going to ask you to do a couple right now.